Bismillahirrahmanirrahim. Hello and welcome to Rahman Digital Production. This is the 50th lecture of Physics 5054, and we discussed the theoretical portion of chapter number 8 till the last video. Today we are going to discuss the exercise 8, which is on page number 128. The first section, which is called section A, contain multiple choice questions. The first question is saying water is not used as a thermometric liquid mainly because it. Number A option is it is colorless. Yes, that is why we are not using it. It is bad conductor of heat. Yes. Doesn't expand uniformly. Yes. Has low boiling point of 100 degrees Celsius, and that is the correct option, because water is having a low boiling point of 100 degrees Celsius. So it means that you can record a temperature till the 100 degree, but if a human body or someone else is having 101 or 102, this thermometer will not be able to record it correctly if it contains the water. Number 2. So in this case, number 1, I am writing D is the correct option. Second number question is saying that which of the following thermometer is the most suitable for measuring rapidly varying temperature. Without seeing the option, I am telling you that in yesterday lecture we discussed thermocouple thermometer, and that is the answer. Now let's see what they are saying. They are saying that the first option is thermocouple thermometer, and that is correct option. The second option is mercury in glass thermometer, alcohol in glass thermometer, platinum resistance thermometer. So in the second MCQ, there is A part is the correction option. Okay, number C is saying a mercury in glass thermometer and a thermocouple thermometer are both calibrated using the same fixed points of 0 degrees Celsius and 100 degrees Celsius. When both thermometers are used to measure the temperature of a body, the temperature measured on both thermometers will be exactly the same. Number A part, for all temperature between 0 and 100 degrees Celsius, that is not the answer. It will not be the same. Only at the fixed point, yes. That is the correct answer, because at fixed points the both the thermometer will show the same temperature, but not for all the points. Number 4 is saying a clinical thermometer has a narrow capillary tube so that it, number A part, is quick to respond to temperature change. No, it is not. Can record the maximum temperature. No, it is also not. Show a larger change for a given thermometer rise. Yes, that is the main purpose of that capillary tube which is made narrow show a larger change for a given temperature. It will show, because if it was of a larger diameter, so it won't be able then to give you the correct answer. Okay, in the fourth number question there was part number C. Now we are coming to section number B, and that is the structure question. You have to prove your answer in that case. Ladies and gentlemen, in structure question, the first question is complete the table below. Type of thermometer it is written, and thermometer substance it is written, and empty place is the thermometric property. So mercury in glass thermometer is using thermometric substance mercury. Which property of thermometric property it will give you? They given us a table in this form, and the third column is empty. uh, First they are saying thermometer and thermometric property, thermometric substance and thermometric property they are using. These are the empty places. The first is saying mercury in glass, mercury in glass, and it is using mercury as a thermometric substance. And which thermometric property it is using? Fixed volume, volume of a fixed mass, and similarly length as well. These are the both are the thermometric properties mercury in glass thermometer is using. The second one is platinum resistance thermometer, platinum resistance thermometer. Ladies and gentlemen, it is using platinum wire as a thermometric substance. Platinum wire it is using. So what thermometric property it will use? And that is the resistance. We studied these things, but let me refresh your memory for this. Number second question is saying that what are the two fixed points chosen in the calibration of the centigrade Celsius scale? Uh, we talked about that there are 2 points. One is the ice point, and the second one is the steam point. These 2 points are used as the upper and lower points of the uh, centigrade or state their values and briefly explain why such fixed points are the 0 degree Celsius and 100 degrees Celsius. These points are required to calibrate evenly, to divide evenly the degrees inside between these points, and that is 100. So for that particular purpose, the lower fixed point and the upper fixed point are required. You have to measure those 2 points, the distance between these 2 points, and then you have to divide equally the division between these 2 points. That is why we need the upper and lower. Third question is saying describe a laboratory experiment to determine the two fixed point of a mercury thermometer. Ladies and gentlemen, we did these things in greater detail in one of the previous lectures. So if you want to see that how we are finding these 2 points, so we were using a funnel in which there was ice cube and the thermometer bulb was inside that, and shape of the ice were used. In the second case, we were using the manometer. In this case, you can see that how we can find the two fixed point. Refer to my 48 or 47 lecture in which we discuss in greater detail. I don't want to waste your time on this again. So that was the whole story about question number 3. Question number 4 is saying, in the construction of a clinical thermometer, what are the factors that must be considered to ensure that it will be sensitive to small temperature changes? The fourth question, that was the third question, and fourth question is saying that what are the factors so that it will be what, it will be sensitive to temperature. One, the glass uh, wall should be thin. uh, this is the first factor, and the second factor is that there will be a capillary bore which will be very much fine, that will be fine, so it will be sensitive. A small temperature change will show the movement of mercury. So these are the factors that it must be sensitive to the temperature. Okay, this was the A part. What are the upper and lower limits of such a thermometer in degree Celsius? This was A part, and B part. There was 43 degrees Celsius to 42 degrees Celsius. Why? Because I told you in one of my previous lectures that the human body, which can record normal temperature, is between these two. So that is why that is 39 point something. So the calibration is between these two. The third part is, what is the temperature in Kelvin of the healthy man whose body temperature is 37 in Kelvin? If we want, then we will add 273 plus 37, 273 plus 37. So when we add this, we will get the 300 degree Kelvin. uh, 310, 310 will be the, yes, 310 degree Kelvin, because we have to add 273 with that of 37, and that will give us the answer. Ladies and gentlemen, these questions are comparatively easy because we did all the parts of this. So just memory refreshment I am doing. If you want to see it in greater detail, then you have to see my previous lecture. 5 number. An uncalibrated mercury in glass thermometer is immersed in melting ice. The length of the mercury thread is 25 millimeter. So L0 is 25 millimeter. Then what happens? When the thermometer is immersed in steam from pure water boiling under a pressure of 1 standard atmosphere, the length of the thread is 200 millimeter. So L100 is equal to 200 millimeter. Then what happens? What is the temperature in degree Celsius? We have to find the temperature in degrees Celsius when the length of the thread is 95 millimeter. So L theta is 95 millimeter. Keeping in mind these things, we can find the theta, which is equal to L theta minus L0 divided by L100 minus L0 multiplied by 100. That is the formula we will use, and if you remember, we use that in different work example as well. So L theta is 95 minus 25 and L100 is 200 minus 25 again multiplied by 100. So theta in this case is equal to 70 divided by 175 multiplied by 100. And when we uh, do the calculation, theta will be equal to 40 degree Celsius. So that was the whole story about the A part. Now we are going to discuss the B part. Give 3 advantages of the uh, use of mercury in preference to other liquid in a liquid in glass thermometer. Ladies and gentlemen, we did this thing. Number one is this is the A part and this is the B part. The question is saying that why we are using mercury and we are preferring mercury in liquid in glass thermometer on the other things, just like alcohol and many other liquids which are used. The first one is it doesn't wet the tube. It does not wet the glass tube. It does not wet the glass tube. The second one is it expands uniformly. It expands uniformly. Yes, this is another preference because water and other things are not expanding uniformly. It has a visible meniscus. It has a visible meniscus, we can see that inside the glass thermometer that tell which place the mercury reached, it can shine. So we can see the meniscus of this mercury very clearly, and that is why we are using these things. Ladies and gentlemen, that's it for today. There are 2 3 other questions, but I am leaving that for tomorrow. Thank you very much for watching. Allah Hafiz.